which is approximately 0.707. And you keep going. Next angle up, not straight up, but 60 degrees to pi over 3. So what's the x coordinate up there? We're talking about this one. What's the x coordinate up there? A half, right? Are y'all seeing what I mean here? This is the x being plugged in, which is an angle, and this answer is not this x, it's the x coordinate off the circle. So they're distinct things. And then finally, pi over 2, let's go straight up. Cosine of pi over 2, 0. And then we keep going around, right? So I have another picture. I won't turn off the lights, but I have another picture of what cosine looks like. Oh, wow, what the heck? So do y'all see at 0 degrees, at 0 degrees, cosine is 1. So you can see at 0, I've gone up 1. What's going to happen to the x-coordinate as I start to move this point across the circle? The x-coordinate's going to get what? Bigger or smaller? Smaller. It's going to head to 0. So I'm going to start moving towards, there's pi over 3. Oh no, there's pi over 6. There's pi over 4. There's pi over 3. And so do you see on the graph, we started up here at 1, and then as I move, as I rotate, the angle gets bigger. The x-coordinates get smaller. And then my x-coordinates are going to become negative until I get to there. At pi, my x-coordinate is negative 1, which is why this is down 1. And then I keep going around and eventually come back to 2 pi right there. And this is the graph. It looks kind of like the sine, doesn't it? There's a little bit of a difference though, right? I'll graph them together. There's sine x. There's cosine x. Oh, no, there's not. There's sine x. There's cosine x. The red is sine. Also, let me change this to step it by pi over 6. Pi over 12. There we go. Can't quite get, there we go. I can kind of get it in there. The red is the sine function, the blue is the cosine function. They're very similar to one another, right? It almost looks like if you moved the cosine, the blue one, to the right a little bit, they would land right on top of each other, right? We'll talk about that later. It's called a phase shift. If we just move it over, then we would get the same graph. Okay, so that's the graph of cosine. And so what we want to be able to do is we want to be able to graph these by hand. And we want to be able to change things within the function to get a different shape. Like just like when you were learning about parabolas, you learn about x squared, and then you talk about, oh, what if it's 3x squared? And oh, what if you do like x minus 2 in parentheses squared? These shifts and up and down and stretching, all that stuff. We want to be able to do the same thing for sine functions and cosine functions. Do y'all feel like you understand how the sine and cosine are connected to the unit circle? Do you feel like you've established that in your mind, like the connection? Yeah? Okay, let me see if you can figure this one out. What if I tell you that for cosine squared x, okay, so what I mean by this is a notation we technically haven't talked about yet, equals to find x if 0 is less than x is less than 2 pi. All right, so this notation I just wrote on the board, cosine with a 2 here of x. What this means is the cosine function squared. Okay, that's what this means. When I write this, I mean this. All right? So I'm asking you to look at this, and I'm telling you that cosine 4 times cosine squared of x equals 2, and I want to know what x is. This is similar to the problem I just gave you. A minute ago I gave you this problem, right? Sine of x is a half. And I asked you to figure out where, what x gives you this, right? Yeah? And everyone said that they understood that this was asking where's the y-coordinate on the unit circle equal to a half, right? That problem is a similar problem. I'm asking you to solve an equation for x, but it's not as simple as this, right? Like this, I just say y-coordinate is a half. That one's not so clear. So, y'all ready? I'm going to show you how to do this one first. So what I'm going to do here is, it's an equation. I'm going to divide both sides by 4. Two divided by 4? 1/2, right? So I'm just dividing this side by 4, dividing this side by 4. I get that? Yes? Now, is this asking me where the x-coordinate on the unit circle is a half? No. Why? Why is that not what it's asking? Yeah, because this is squared, right? If this wasn't here, if the 2 wasn't here, if that squared wasn't there, then that would be asking where on the unit circle is the x-coordinate a half. But because the squared's there, that's not what's being asked. So in order to get rid of the squared, I have to do square root on both sides, right? So let me do that. If I take the square root of the left side, and I take the square root of the right side, you get, on the left side, you just get cosine x, which was the whole reason I took the square root, right? Was to kill off the squared. On the right, though, I took the square root of a half. A very important part here, I'm missing something. What am I missing? Plus or minus. Anytime you take the square root on both sides of an equation, you are the one who actually does it. You come in and take square root, both sides. You must remember to do plus or minus. Because there's 2 potential answers, right? There's 2 potential answers. Y'all think about it this way if it bothers you. If I write x squared is 4, there are 2 solutions to this, 2 and negative 2. If you take the square root on both sides, and you forget to do plus or minus, you're just going to tell me the answer is 2, and that's not the only answer. You have to put plus or minus. When you initiate the root, you remember the plus or minus. So, I'm here now, right? So this is asking me, now I can say, where on the unit circle, at what angle, is my what coordinate? X coordinate. Why am I saying x coordinate? Because it's cosine, right? Good. Where is my x coordinate what? One of those, right? Positive. Well, do you remember on your unit circle quiz, did you ever put that anywhere on there? Was that one of your common angles that you had, or common numbers? It actually is, okay? It is. You have to recognize this as being the same as plus or minus 1 over root 2, okay? Because I can do the root of the top and bottom. Square root of 1 is 1. Square root of 2 is 2. And then if you rationalize the denominator, which I said you don't have to do, right? Like mechanically, we have calculators to do this, but we need to be able to recognize this point off the unit circle. So if I now multiply the top and bottom by root 2, what would I get? Plus or minus what? Root 2 on top and on the bottom? 2. That's rationalized. Now, does that look more familiar to you? Where on the unit circle, with an angle between 0 and 2 pi, do you have an x-coordinate of positive or negative root 2 over 2? Who wants to give me the first answer? Who wants? What is it? Pi over 4. So you're thinking right here, right there, your x-coordinate, I'm looking at x-coordinate because it's cosine, is root 2 over 2. Good. Who else? Who said that? Someone else. You said negative pi over 4? Just careful. Remember what I said here. I'm forcing you to give me an answer between 0 and 2 pi, so you're not allowed to give me a negative angle. But what's another way you could have said negative pi over 4? Instead of going backwards, go around this way. 7 pi over 4. So over here, right, this has an x-coordinate of root 2 over 2. Good. So, oh, I'm not writing these down. X equals, one answer was pi over 4. That was this one. And then now we have 7 pi over 4. Any others? It says positive or negative, right? So 3 pi over 4, because here is negative root 2 over 2, right? So that's 3 pi over 4. And last one. Good, 5 pi over 4 here, because the x-coordinate here is negative root 2 over 2. Right? I'm not writing the y-coordinates because I don't care about the y-coordinates because we're talking about cosine, not sine. And so my last answer here is 5 pi over 4. And if you just want to kind of match these up so you know where they are, this one was here, this one was this one, no, I'm making a mess, and then this one is that one, right? This is called a trigonometric equation. And in my Cal 1 classes, when they walk in, I say, welcome to Cal 1. You all took pre-cal. In pre-cal, the two main things I want you to know are this: the unit circle and how to solve trig equations. This is an introduction to your first trig equation. I'm actually ahead of, the book does this later, but I want you to see it now, okay? Because we can do this right now, right? I mean, we just did it. The only tricky part was algebraically solving for the cosine. Once you're here, though, it's just a matter of you understanding the circle, right? Y'all okay with this? I feel like I want to push a little further on this. Can I? Is that all right? No choice. You don't have a choice, so I'm pushing further. How about this question? If cosine of x equals 0, find x. Now this is going to be a real test of whether or not you understand this. Who did I not call on last time? No one's going to tell me, right? Do I have to look? Does somebody want to volunteer what this is asking in terms of the unit circle, like what this is asking? Go ahead.
It's asking at what point in the unit circle is the x-coordinate of the unit circle going to equal 0?
Yes, almost perfect. It's asking at what angle on the unit circle, right, is the x-coordinate 0. I think he said at what point, right? But x is the angle. So we're saying at what angle on the unit circle is your x-coordinate 0? Perfect. That's it, right? So do you want to give me an angle where the x-coordinate is 0?
3 pi over 2.
So you're choosing to do this angle right here, 3 pi over 2. Does everyone agree at that point on the unit circle the x-coordinate is 0? So x equals 3 pi over 2 would be a solution. Is it my only solution?
No.
Okay. Someone else want to give me another angle? Go ahead. Pi over 2 would work as well, right? That would be from here to here. That's pi over 2. This one is 3 pi over 2, right? So now I have pi over 2. Am I done? I heard someone else say something else. What? So at angle 0, what's your x-coordinate?
0.
Your x-coordinate. It's 1. Okay, you understand? Yes? I agree. These are the only two places, if I'm looking at the unit circle, the only two places where my x-coordinate is 0 are at the bottom and at the top, right? However, I'm not done. Because what if I told you to rotate this way? Do y'all see on this problem, I didn't put a restriction on x. I didn't tell you x had to be between 0 and 2 pi, did I? So now you're allowed to go backwards. So what would be backwards from here to here? Negative pi over 2.
Could you just do plus or minus pi over 2?
You're starting to see it. I could also do this, right? Come here and go to there, right? And go backwards like that. What would that be? If I rotate it from here to there. Negative 3 pi over 2. Right? Am I done now? Nope. I'm not done. Because what's stopping me now from doing this? How about this angle? Go all the way around once and then to here. Wouldn't that still be an angle that gives me a cosine of 0? Yes? How many answers are there? An infinite number of answers. Right? How do we write that? How do I tell you that? Are you all with me? Now, it's not all real numbers because it can't be anything. It can't be 0, right? It's not, cosine of 0 is not 0. But there are an infinite number of answers. So watch, pay attention, this is important. See if you follow this. I think you can. I wouldn't be asking us to look at this if I didn't feel like you could follow this. These are the only two places on the unit circle where this is true, right? The only two places. What I'm seeing here is that all I really need to do is figure out what this angle is. That's pi over 2, right? So my answer, x, is pi over 2. But I can also rotate by another how much to get to the other answer? Jeez. If I rotate by another pi, right? If I add pi to this, I will be here, right? And if I add another pi, I will be back here, right? And if I add another pi back here, another pi here, another pi here, or I could have started at the blue one and subtracted pi, subtract pi, subtract pi, subtract pi. And it'll keep giving me half rotations and just kind of spit me back and forth between the 2 points, won't it? Yes? So what I'm going to write here is pi over 2. That gets me started. And then because each jump is a half rotation, I'm going to put plus pi k. Now k is going to be an integer. I need to state that. K is any integer. I think I wrote on the board the other day what an integer is. Remember, an integer comes from that list. 0, 1, -1, 2, -2, so on and so forth in both directions forever. If I write this, this covers all the answers. That is all infinitely many solutions represented in a nice clean answer. Now, if you don't believe that, let me just try to explain it. I want to leave this here. What time is it? 2? Do y'all have any questions right now on that? How I got that? So think of it this way. I can start spitting out the answers like this. I'm just going to pick in some values of k. If k is 0, what's the answer? Pi over 2. Okay, what if k is 1? Because remember, k can be any integer. If k is 1, what happens if I put a 1 there? I get pi over 2 plus pi. How do you add pi over 2 and pi together? You get a common denominator. Pi over 2 plus pi over 1. Multiply the top and bottom of this fraction by what? 2? 2? What's that answer? What's pi plus 2 pi over the common denominator? 3 pi, right, over 2? So this is 3 pi over 2. So far, I've got those two answers included. Do you see that? Let's do k is 2. What if k is 2? Now I'm doing pi over 2 plus 2 pi. I need a common denominator. What would happen if you put this over 1 and multiply top and bottom by 2 there? It would be pi over 2 plus what? 4 pi over 2, which would be how many pi's? 5. 5 pi over 2. Y'all with me or not? That's not on this list, right? I never had 5 pi over 2 over here, but it's an answer. It's kind of a pain in the ass to have to get this common denominator, right? Every time I'm doing this, it's kind of a pain in the ass. So watch. What I can do is I can take this answer, and I can get a common denominator here. Okay, so I'm taking this answer, looking at this as a 1, and I'm multiplying top and bottom by 2, and I get this. You'll see that? Now I put them together, and this is pi plus 2 pi k over 2. That is the same answer as this answer, but it just looks a little different. Do y'all see how that's just a different way of writing the same thing? What's the advantage of that? Look how easy it is to plug in k. If I plug in 0, what happens? 0 here, what do you get? Pi over 2, right? What if I plug in 1? That's a 1. This is pi plus 2 pi, which is 3 pi over 2. That's this answer. If I plug in 2, what's 2 pi times 2? 4 pi plus pi? 5 pi over 2. You see how much faster it is now? If I plug in 3, what do I get? 7 pi over 2. How about some negatives? What if you plug in negative 1? Because remember, integers can be negative. Plug in negative 1. What's pi plus negative 1 times 2 is negative 2. So what's pi? Take away 2 pi. Negative pi over 2. And that's this one. You see I have all of the answers? All infinitely many answers are represented by that or that. So in this class from here on out, if you write, something like this plus pi k, we are all going to understand that k is an integer. You don't have to tell me that each time, even though real mathematicians would make sure that they state that, but it's understood in this class that when you do this, k is an integer. In calculus, a lot of times we don't use k. In calculus textbooks, a lot of times they use n, and it's understood that n is an integer. So just be kind of open to that idea. Let's try another one. What if I tell you that sine of x equals negative root 3 over 2 and ask you to find x? Who wants to tell me in words what this is asking us to do? Like in terms of the unit circle. Where is what? At what angle is what equal to negative root 3 over 2? Not sine of x. You're saying it right. At what angle on the unit circle is the y coordinate, right? Because we're talking about sine. The y coordinate negative root 3 over 2. So I'm going to draw a quick picture. Y coordinate negative root 3 over 2. Right there, right? Those two? Those are the only two places where the y coordinate's negative root 3 over 2. Right there and right there. There's two places on the unit circle. What are those in terms of our common angles? What's this angle right here?
4 pi over 3.
Is it 4 pi over 3? Okay, so that's 4 pi over 3. I'll put it right here. That's 4 pi over 3. And then what about this angle from here to there? That's another common angle, right? What's that? That's 5 pi over 3. Now, very important. On this picture, when I would try to get my general solution, right, this general answer, what I did is I said, hey, look, if I just go up to this one, then to get to the other answer, I just have to keep jumping by pi, right? Just jump by pi each time, and then I'll be back and forth between the two answers. Because that worked because there's symmetry here, right? They were exactly opposite on, opposite sides of the circle. So it just took half rotations, right? Are these going to give us the same symmetry? Is there an easy way to just jump from one to the other? Doesn't look like it, does it? Right? It doesn't look like, if I wanted to jump from here to here, I would have to go by this much, right? But if I go by that much again, I'm not going to be on one of the answers. Do y'all see that? So what I'm going to do is I'm going to need to have two, I erased it. I need to have two general solutions, one for each of these. So let's start with this one. X will be this one here, 4 pi over 3, plus, now, how can you get me back to that same location? What are you going to have to add to jump right back to where you were? You have to add a full rotation. You have to add 2 pi to get back there, don't you? 2 pi k. See, this right here represents, this is where we're starting, 4 pi over 3. And then any other answer is going to be that plus a full rotation or minus a full rotation. And that will get you back to where you were, right? That's the infinite representation, or this is the representation of the infinite number of answers that correspond to that point on the unit circle. Now I need this one. Yes?
So every time it will be 2 pi k?
Well, this one wasn't, right? This one was pi k, and that was because we could get from this one to this one by jumping by pi, right? But if you can't jump by pi to get back and forth, and you have to go all the way around, then it'll be 2 pi. Look at this. What if, and there will be problems like this later, what if our solution to our equation were those 4 points? Can you jump from one to the other? By adding how much each time? Pi over 2. So if you jump by pi over 2, you're going to go like this. You see that? So here you would add pi over 2k. Making sense? Here, there's no easy way to jump. So I'm just going to start at this one, go all the way around. That's that answer. And then go to this one and go all the way around. Yes?
So does it depend on where the points lie?
It depends all on where the points lie. Whether or not there's symmetry or not. Here there's symmetry. Here there's symmetry. Here there's not.
So
Yeah?
if there's not symmetry, is it usually we would use 2?
You would go 2 pi, yes. If there's no symmetry, you have to add 2 pi. Yep. All right, this answer, 5 pi over 3 plus 2 pi k. You have 2 sets of general solutions for this. Okay?
Isn't negative pi over 3 and negative 2 pi over 3, aren't they also solutions?
Yes. Well, they're not. I think what you're asking me is, instead of looking at it this way, right, could you have done this idea? You still have these 2 same locations, right? But instead of coming around this way, could you have said, look, I'm going to go from here to here. That's negative 2 pi over 3. And then I'm going to go from here to here, and that's negative pi over 3. And then do the same thing. So one of these would be negative 2 pi over 3. The other one would be negative pi over 3. And you would still add the full rotations, right? To get back and forth. Would that be an acceptable answer? Yes. Because your list of answers is the same as my list. It's just where we're starting from is different. So if we were to create this table, right? You create a table for all values of k, and I do it for mine and you do it for yours, we're going to have the same list of numbers. Does that make sense?
Yeah.
Yeah. Like I think for you, for yours, if you did this, let me see. If you did this one, negative pi over 3 plus 2 pi k, that would be this one, right? This answer there. If k is well, let me see here. 6, 3. So if k is 2, if k is 1, what the hell? Negative pi over 3. Hold on, I'm doing something stupid right now. Trying to get to this one. It was plus 2 pi k. We agree this is negative pi over 3?
Yes.
Okay, so if I get a common denominator here, I have to multiply top and bottom by 3. So that's 6. And then this is 3. How do we make that a 4? What the hell?
You're looking at the 5 pi over 3.
Yeah, you're doing it.
Oh, yeah, I'm sorry. I was looking at this one. You're right. Thank you. I'm losing my mind. Okay, so if I let k be 1, right? If you let k be 1 here, you get my answer here. So your k being 1 is my k being 0. That make sense?
Yeah.
Okay. Then you have the other one. You have to do this one as well. So it doesn't matter where you start. Like your starting angle, you can call it anything as long as it's coterminal. Any coterminal angle here would work.
Okay.
Okay? Like on this one right here, I started at pi over 2, didn't I? If I wanted to, I could have started at negative pi over 2 and then add pi k. Or I could have said, let me start at 3 pi over 2 and add pi k. We're going to do a lot more of this. I just really wanted to see how y'all would handle it, okay? Because it's, I think you're getting it. I think you are. All right, let's get to the graph. We need to get to the graph. So when it comes to graphing sine and cosine functions, we have the basic idea of what the sine and cosine look like, right? I showed you it's a basic idea of these curves. What we want to be able to do now is graph something like this. Instead of just sine of x, what if I put something like 4 sine x? So I multiply by 4 in front. So the way that we're going to go about this in this class, when it comes to sketching, is we're going to draw our graph, and we're going to pick the common points, the common angles that we're familiar with. We know what's happening at 0. We know what happens at pi. Know what happens at 2 pi. We also know what happens at pi over 2, and we also know what happens at 3 pi over 2. Now, we know a lot about what's happening at like pi over 6 and pi over 3, but those are like the main quadrantal angles, right? So think about what a t-table would look like here at our quadrantals. Here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I plug 0 into this,